of x, let's put it here one more time because I'm gonna show you the two definitions for f prime of a.
F of
Limit.
limit
A, yes,
times h equals 0
good.
f of x plus h minus f of x over h.
Perfect. So there is only one definition for the derivative as a function, just one. However, there are two definitions for f prime of a. It's the same thing, written in two different ways. That's all it is. So f prime of a, no one will indicate which one of these two you should be using, right? However, for certain functions, one is easier than the other. So of course it has to be a limit. If I replace a here, this is very easy to remember. If I replace a here, then I will have to replace a here, and I will have to replace a here. So I replace this by a, then this is a, and this is a. Everything else stays the same. So that's one option. F of a plus h minus f of a divided by h. The second option is when x approaches a, from f of x minus f of a divided by x minus a, which is the slope of the line passing through those points. Okay, this is the end of chapter 2. But I would like now to go to page 151 and practice. Of course, they're all the same. So I'd like to look at problem 19 before we choose an example like this. 19 on page 151. It just caught my eye. If an equation of the tangent line to the curve, so this is the curve or function, here's the tangent at y equals f of x is y equals 4x minus 5 at a equals 2. We're asked to find f of 2 and f of negative 2. So one more time. We have a function. So I'm going to graph a function. This is f of x. Then the tangent at this function at a equals 2, okay. The tangent at this point, the tangent, here it is, has the equation y equals 4x minus 5. Can anyone give us the slope of this line? Very good. The slope is 4. Do you all agree with the slope being 4 for the tangent line to the graph of f of x when x, or a if you want, is 2? Would you agree? Yes? So now I'm asking you, how much is f prime of 2? Of course. Of course. That's what the derivative will give us. The slope of the tangent line to the graph of the function at that point. If the slope of the line is 4, f prime of 2 must be 4. Agreed? Okay, final question. We're asked to find f of 2. How much is f of 2? Remember, this is a point on the tangent as well as on the graph of the function. So how much is f of 2? Very good. 4 times 2 minus 5. 8 minus 5, which is 3. Very good. Okay, so now let's choose a problem and determine f prime of a. Would you prefer a polynomial? Would you prefer a rational again? Would you prefer a radical? A radical, very good. So let's look at a radical. So on page 151, let's say 31, on page 151. So f of x equals the square root of 1 minus 2x. we're asked to find f prime of a. We have to make a decision which of the two definitions we would like to look at. Since we've been using this one as a limit of the difference quotient for a while, let's this time try this. See what happens. Okay, f of x minus f of a over x minus a when x approaches a. Good. So, please dictate. So f prime of a will be limit as x approaches a from, again, no one is indicating one or the other.
So the square root of 1 minus 2x minus what would be the square root of 1 minus 2x
Divided by,
h. Or x.
in this case, x minus a. Yes. Actually, this is a probably better definition for this particular function. Okay, so of course I have to plug it in. What do you think I'm going to get?
0, 0.
Of course, it is 0 over 0 indeed. So then, in this particular situation, what do I need to do?
Multiply by x.
Very good. The square root of 1 minus 2x plus the square root of 1 minus 2a divided by square root of 1 minus 2x times 1 plus 1 minus 2a. Very good. Awesome. Next, of course, is limit. Please remember, you cannot drop, I know I sound like my grandma. You cannot drop the limit operator till the last step. It will make no sense. If I write now without the limit, they are not equal. It's false. Good. Can anyone give us the top and I will write the bottom?
One minus 2x minus 1 plus 2a.
Very good. Awesome. So we already distributed at the top. That's very good. So now, can anyone tell us what is the factor that is creating 0 over 0 that I'm hoping to get rid of?
X minus a.
Of course. X minus a is the problem. Thank you. Good. Awesome. Good. So then these two obviously go away. Establishing the fact that I need to get rid of an x minus a, what do you think I'm going to have to do in the numerator?
Factor out x minus a.
Careful. I have negative 2x and positive 2a. That's why I asked you one more time, what is the factor that needs to go away?
Negative 2.
Very good. So the factor that needs to go away is x minus a. Therefore, I need to factor out negative 2. You always factor out the leading coefficient. If the leading coefficient is negative, you always have to factor out minus blah, blah, blah. Okay, so what is in parentheses? Of course, that's what I wanted. If I hadn't factored out negative 2, I would have not gotten this. Perfect. So now?
Get rid of it.
Exactly. 1 and 1. And now at this point, I can drop the limit operator. The numerator is negative 2. Can anyone give us the denominator? Careful now. X approaches a. There is no x here, but there is an x here. So when x approaches a, what do we get?
2 root 1 minus 2a.
Very good. We continue to simplify, and the answer becomes
1 over
negative 1 over the square root of 1 minus 2a. Very good. This is the end of chapter 2. This is the previous test from chapter 2. So let's start working on this. Please bring it with you. I'm not collecting this, but we were not going to be able to finish it today, and I want to finish it on Thursday, so please bring it with you. Thank you.
Are you gonna upload a video or something? Or are you making a video or something?
When we finish it? Yeah, but I will ask you to work on this But the problems that the problems that we don't finish tonight, I would like you're in charge, but you're not doing your job. Okay, minus 5 points on the first, on test 1. Yes, absolutely.
Okay, you still have your report.
I'm telling you, either chemist or minus 5 points, one or the other.
That's not bad.
Yeah, I think you should try chemistry. Good, very good. So, any questions on this? Okay, let's start. Okay, so this document is yours, but please don't forget to bring it on Thursday. And the checklist is due on Thursday. Turn in a copy so you can check the solutions between Thursday night and Tuesday. Yes,
What are we doing right now?
I'm sorry.
What are we doing right now?
You're working on problem number 1 with pencil and paper. That was cute. What are we doing now? Remember, the checklist is a complete summary of everything in chapter 2. Whatever we don't accomplish today, because we're not going to finish in 20 minutes, I would like you to look at and come up with answers for Thursday. Okay, so the checklist and this. And we'll continue working on it in class, but I would like you to review it at home. Do not forget to review the limit document. Okay? These 2 pages. First 2 pages from the limit document. Do we have an answer for the first one? When you plug it in 0, what do you get? 0 times undefined. What does that mean? What is the only option? 0 times undefined.
Can you tell me?
Look at this. Say it again.
Zero.
Look at, say it again.
Can you tell me?
No. Indeterminate cannot be undefined. So this is 0 times undefined. What do we do in this case? Look at this function and say, I remember.
You make a table.
No.
Is it the
Zero.
squeeze theorem?
Say it again.
Is it the squeeze theorem?
The squeeze theorem. So let's apply the squeeze theorem, please. Show the two functions that squeeze this function and clearly state what the limits are and clearly state the squeeze theorem. Very good. Thank you, Robbie. Do not forget the squeeze theorem. Especially when you see a sine or a cosine in there. That's also a hint. And also when you think of 0 times undefined. Okay, are we ready? We need more time? Okay. Ready? Yes? Where do we start? With always? Yes, we plug it in, so this is 0 times undefined. We don't know what that is. So then we start by trying to build this function. Where do I start with?
Cosine.
Yes, cosine pi over x is between always.
-1.
Very good. Now, I am not there yet,
You would multiply by the square root of x.
making sure that this is always positive and never 0. It's never 0 because x approaches 0, not 0. So I'm safe. It's positive and not 0. So negative the square root of x less than or equal to the square root of x cosine pi over x less than or equal to the square root of x. So this is the first hypothesis of the squeeze theorem. Show that the function is squeezed. I did show that the function is squeezed by finding f of x and finding g of x, two different functions. In step 2, I have to show that
Limit
as x approaches 0 from the right from negative the square root of x is, and yes, and limit as x approaches 0 from the right of the square root of x is, and yes, they are both 0. Then from 1 and 2 together, from 1 and 2 by
squeeze here.
the squeeze theorem, what do I conclude about our limit? Limit as x approaches 0 from the right from the square root of x cosine pi over x must be also 0. Excellent. Now, we can do this, but I think we've done like 3 problems. Can we do this at home and check it on Thursday? Okay, so let's move on, because I like to accomplish as much as we can. Okay, so we have a function. It's what type of function? Piecewise is defined in 3 pieces. So let's graph this function and then answer the questions. Remember, when we graph a function, the setup is find the domain, create a table of values and ordered pairs. Make sure you plug in correctly. Make sure you find those signs under those numbers, the thresholds, and then graph the function. And only then we can answer the questions. Nick, are you okay? You need any help?
No.
If you need help, anyone, please let me know. Do we need more time on this problem? Is that a yes or a no? Ready? Every time we graph a function, we need to identify its domain. That's the first step. This is the same with negative infinity to negative 1. Agreed? This is the same with negative 1, 2, and this is the same with 2 infinity. Can anyone give us the domain of this function?
Negative infinity to negative 1. Negative 1 to infinity.
Awesome. Do we all agree with this? Everyone? Okay. Now I get my chart going. In the chart, I have to have negative infinity, I have to have infinity. I have to have negative 1, I have to have 0, and I have to have 2. Why 0? 0 has to be in the chart no matter what. Negative 1 is a key value, and 2 is a key value. Now tell me the signs under or symbols under negative 1. Left parenthesis, very good. Empty. And right parenthesis, which means the function is not defined at negative 1. Symbols under 2, or parenthesis to your left, and touching bracket to the right. I know it's an overkill, but it's a good habit. Which function, because these may not be arranged in left to right order. So what is the first function here? Very good. Obviously in the middle a quadratic function, and then x plus 2. Okay, good. So now let's plug in, let's say negative 3. 1 minus negative 3 is 4. The square root of 4 is 2. When I plug in negative 1, I have the square root of 2. When I plug in negative 1, I have 0, right? Negative 1 squared is 1, 1 minus 1 is 0. When I plug in 0, I have negative 1. I also have to plug in 1 because I get another x-intercept. When I plug in 2, what do I get? Right here inside parentheses, 3, very good. When I plug in 2 here, I get inside the bracket 4. And then when I plug in 3, I get 5. That's all I need. Ready to graph? Any questions? Everyone is comfortable with this? Yes? Okay, perfect. The first ordered pair from left to right, which one? Very good. Negative 1, the square root of 2, square root of 2 is roughly 1.4. So negative 1, 1.4, what type of point is that? And remember, this is a square root. My graph is not very good. Make sure it's not a straight line, because it's not a straight line, it's a square root. Next ordered pair, please. Negative 1 comma 0, an open point. 0 comma negative 1, 1 comma 0, and 2 comma 3. What type of point is 2 comma 3? What type of function is x squared minus 1? Please do not graph it as a straight line or as a corner. It's not a corner. Finally, 2 comma 4. What type of point is 2 comma 4?
Closed.
Very good. And 3 comma 5.
Closed.
Very good. This is the graph of f of x. Can anyone give us the range?
-1 to infinity.
Perfect, perfect. Very good. Thank you very much. -1 to infinity. Now we're ready to answer these questions. Sketch the graph and determine if the function is continuous on its domain. Is this function continuous on its domain? No. So the domain does not include -1. I shouldn't even mention -1, but I will say it again. At x equals -1, function is not continuous since it is not defined. Good. Is there any other discontinuity? At x equals 2, function is not continuous. It has a jump. If the function is not continuous at a point, determine if it is continuous from the right or from the left. It cannot be continuous here from the right or from the left because it's not defined. So now let's identify whether it's continuous from the left or right at the other point. Is it continuous from the left or from the right? From the right. At x equals 2, limit as x approaches 2 from the right of x plus 2 equals f of 2. Therefore, f of x is continuous from the right of x equals 2. You must present the definition of continuity of a function at a point. It's on the checklist and we had it. Can anyone remind us the definition of continuity at a point? Limit as x approaches a from the left must equal the limit of f of x as x approaches a from the right, and it must equal f of a. This is something that we can never forget, like those graphs, like the definition of the derivative, like so on and so forth. This is the definition of continuity at a point, and we have to remember it. Present domain and range, we did. Present the table of ordered pairs, we did. Does the function have a removable discontinuity? No. Removable discontinuity means something like this. Both sides go to the same point and the point is not there. But both sides have to go to the same point because the limit from the left and limit from the right have to be the same and exist. Okay, so does the function have a removal? I'm going to explain, and I'm going to say there is no point at which f of a equals, it does not equal limit of f of x as x approaches a from the left, which equals the limit of f of x as x approaches a from the right. There is no such point. Therefore, there is no removable discontinuity. Any questions? Okay, I would like you to work on this at home because we had several examples. Remember, when you graph the function, you have to graph the asymptotes. And since I have 1 minute left, let's do just one from the limits. Please complete everything else. There are only 11 questions, 12 questions, and the last one is extra credit. So you can complete everything here. You've seen everything here in class. But let's do just one and stop. Just the limit as x approaches 0 from the right, from arc tangent 1 over x. After this, we stop. Please bring this with you so we can look at it or finalize it on Thursday. So don't forget, please. Don't forget the checklist. Don't forget the test is a week from today. Don't forget to make a copy of the checklist before you turn it in. And I prefer you keep the copy of the checklist and you just turn in your work. Okay. So, any questions here? Where does this go? We have to have the graph of 1 over x embedded in our memory. As x approaches 0 from the right, 0 from the right, where does 1 over x go?
Positive.
Awesome. Now, arctangent of infinity. We have to have the graph of arctangent embedded in our memory. As x approaches infinity, where does arctangent go? That's it.